What's up, everybody? I'm in the shop today and I'm going to be working on the induction system of my race truck. Originally, I had an L96 intake manifold on it, and those work really well, have a really broad operating range. But with this truck seeing most of its time on the track at high RPM, I thought I could use something that's a little bit more suited for the application. So I found an LS3 Super Victor intake manifold, and I need to do a few things to get the setup complete, and I'm going to show you how I do it. Now, there are a couple things that are unique about this setup in that this is a drive-by-wire throttle body. So of course on the stock intake manifold, it would just go right on the front. And I wanted to keep a drive-by-wire system. So I had to adapt this throttle body to this intake manifold. This is a 4500 Dominator flange. And I just bought an adapter, which there's a few people out there that make them. So you bolt that onto your intake and then you can put your throttle body on top. It makes it really simple. Now that's kind of the easy part. Got the fuel rails on there and everything. It's pretty much good to go. But I was having trouble trying to find a solution for the air filter. Usually you just have, some people put an elbow and then they put the throttle body on the front. You can run your traditional tube with like a cone air filter or something like that. But I didn't want to do that. I wanted something that was maybe less restrictive if it matters, and also just kind of looks cool. So I've seen guys run these big, this is like a sprint car style filter, and I've seen guys run these on these single plane manifolds. The trouble is finding a base plate for the air filter to sit on. Ideally, you would have something that has like a groove in it so this bottom section can sit into it, and then of course it needs to seal pretty well to the intake manifold, so you're actually pulling air through the filter and you don't have, you know, a hole down around the intake where you can suck up dust and other things like that. So I've seen some people do this where they cut, you know, an aluminum plate that kind of fits around here nicely, and that's my intention, but I'm not going to do it by hand. I have some pretty cool tools that are going to help me make a really slick piece that's just going to sit perfectly on here, and then I can mount the air filter on top. The tool that's going to help me do this is a 3D scanner, and RevoPoint has partnered with me. They sent me their MetroX 3D scanner. This thing is really easy to use and really a professional grade product. I've read through the instructions and it's simple as downloading the software onto your PC, plugging everything in, and you're on your way. I really think this is one of those tools that if you're someone who wants to reverse engineer or you want to design stuff from scratch, this is one of those things that's pretty invaluable in the garage. As I get scanning here, something that I'm really focusing on is trying to get into all the little nooks and crannies of the intake manifold. And I want to do this because I want to get as complete of geometry as I can. And I'm also going to take multiple scans of the part to help me achieve that. Because once I go into the post-processing and merge all of the scans together, then I will end up with a really complete 3D model to work with. And I really want to focus around that area of the flange because that's where the base plate is going to mate with the intake manifold. And I just want to make sure that I keep any contaminants out. What's really nice about this software as well is that all the post-processing tools that you need are already built into it. So because I have multiple scans, I can go in and manually align these scans by clicking different points on each scan. Or if your scan has really identifiable features, there's actually an automatic alignment tool so you can get these scans merged together. Another cool feature of this as well is that depending on your computer and your CAD system, you can adjust the quality level of your export so that you can have a finer mesh and a really detailed part. Or if you have a little bit slower computer, you can go for a little more coarse of a mesh. That way your computer can keep up and you can keep designing. Once I got the intake manifold into the CAD program, then it was time for me to actually start designing. So basically my idea was if I could make surfaces for the base plate, I would be able to intersect them and then create this perfect profile to fit around the intake manifold. And I would actually offset it just a little bit just to make sure I had some clearance. But after that, made the grooves for the air filter to fit into, got a really good look at what this thing will actually look like when it's sitting on the intake manifold. That's such a cool feature of using products like this, is that you can truly design something and get it perfect before you get to the real life product. And to take it even a step further, I do have CAD of an LS engine, so I thought I might as well just throw it on top here and really see what it's gonna look like when it's in the truck. So I had to basically cut the intake manifold off that was in the CAD file, and then I put mine on top and got a really good look at it. At this point, all I have to do is just export my CAD file, send it off to whoever I'm gonna have make it, and then in a few weeks we'll be back and see how the part turned out. So it's been a few weeks and I have the finished piece from the machine shop. This is 6061 T6. I've already test fit this thing and it's exactly how I wanted to come out, and this is why 3D scanners are so awesome. It fits perfectly around the flange. I'll show you in a second. There's pretty much no gap around here, so I really don't think I'm gonna have to use anything external to seal it. And then sits on top of the fuel rails, which is how I kind of intended it to be. And then it has a groove that the filter sits into, and there's some clips that you buy to hold these air filters on. So that's absolutely wild that I've taken that from a 3D scan into my CAD program, and now I have the real thing. Now the only thing that I have to do to finish this is actually mount the plate to the manifold. So I'm actually going to do that with these little tabs. These were random tabs that I had laser cut a while back. And what I'm going to do is I'll just bend these at 90 degrees, and then, you know, it'll fit in the corner here from the plate to the manifold, and I'll just drill and tap a hole for a 1032 screw and do that on each edge, and that should be enough to hold it. This material here in the middle is about 3/16 thick, so I should be able to just tap a hole all the way through. And then on the manifold, I won't drill a through hole, I'll drill it almost all the way and then just have a blind hole there. So that should work pretty well. I just got to bend these up and then drill and tap. For the brackets, just a little 90-degree bend. I did end up drilling these holes all the way through just so I could get a good bite on the screws there. So when I do the final install, I'll just put some thread sealant on these to make sure there's no air leaks. But this is really solid and I don't see any issues coming from this. So that's gonna do it for right now. This is what the final setup will look like. So I have my adapter plate and then the throttle body on top. I'll probably have a bell kind of 3D printed just to make the airflow path a little bit cleaner in there. But I want to give a huge thanks to RevoPoint for hooking me up with a 3D scanner, because doing projects like this is really, really difficult, if it is even possible, to get that intricate geometry with the intake manifold and everything. So that's pretty awesome. If you are someone who likes to engineer, reverse engineer, create anything, 3D scanner is a great tool to use. So I've got some work to do on the fuel system before I get the intake manifold actually on the engine. So stick around for next time.